It's a pleasure to make this presentation. The title of the report is A Full Lifecycle-Oriented Flexible Method for Satellite Design. I'm from Institute of Telecommunication and Navigation Satellites, China Academy of Space Technology. There are 5 parts in the presentation. One is introduction, and then definition of satellite flexibility, and then methods supporting the design of flexible. 4. Flexible design of the satellite, and 5. Conclusion. First, introduction. The satellite design is carried out after the user's task requirements are specified, but now there are 2 problems. 1. The development cycle of large and medium-sized satellites is 18 and 36 months, and the time is being further reduced. 2. The service life of large and medium-sized satellites exceeds 10 years and is being further extended. What if user requirements change during the development process and in-orbit operation? This paper presents a full life cycle-oriented flexible method for satellite design, which solves the problems of long period and high cost to realize the change. What's the flexible design of the satellite? Unlike other products, satellites have to experience complex and harsh space environment during launch and in orbit. The cost and risk of satellite in-orbit maintenance is very high, even not repairable. The flexibility of satellite should have the ability of in-orbit maintenance and be able to upgrade its function. A full life cycle refers to 2 stages of satellite development on the ground and flight in orbit. In the ground development stage, the flexibility of satellite means that it can be compatible or easy to complete modification when hardware products and software functions are changed. In orbit stage, the flexibility of satellite means that it can be upgraded when the software function is changed. So, the overall goal of satellite flexible design for the whole life cycle is to reduce the cost. It has 2 means. 1. Shorten the increase in development cycle caused by the change, and reduce the cost of test and test cost by the change of equipment and the whole satellites. 2. Improve the ability of in-orbit software upgrade. Enhance the value of satellite, and reduce the total cost of launching satellite again. A method is here defined as a tool that supports the design in designing satellites in a systematic way, taking relevant parameters into account. Systematic in this context means the theory of system engineering. The requirements are decomposed into different parts of the satellite, and then integrated into the whole satellite through system research and problem solving. Flexible design process, as well as the relevant parameters, should be truly structured in such a method. How to develop a design that adapts to change? The core of the flexible design process of satellites is to adapt to changes. When the design requirements are determined in Stage 1, it's necessary to consider the impact of the external interface changes and the internal interface changes of the satellite on the whole satellite from the perspective of the system. In Stage 2, the flexible design requirements should be considered from the satellite architecture, hardware, and software. Flexible satellite design means changes indeterminate will not have a disruptive impact on satellite design. Now, let's take a satellite as an example to analyze the flexible design. The flexible design of satellite starts with architecture design. The flexibility of the satellite architecture is achieved by the architecture of the electronic system. It can be distributed or centralized, but both have an intermediate layer. The architecture does not change disruptively when there are changes in requirements. In the detailed flexible design, the design is carried out from two aspects of hardware and software. How to carry out hardware flexible design? The hardware flexible design of satellite realizes the installation of single motion and the integration of the whole satellite. There are three ways to achieve 4-star hardware flexibility. 1. The flexible design are realized through the standard interface of local cabin board by adapting compatible, invaluable, and transfer design on the cabin board. The installation requirements of new standard-alone products can be met. The compatibility and envelope design is carried out in the whole satellite design stage and can be realized in the whole satellite production stage. The switching design has no impact on the whole satellite production and can be carried out in the whole satellite design stage and development stage. 2. The flexible design are realized through the standard interface of modular independent cabin. The hatch adapts the standard interface with the hatch section. Different hatch plates can be carried out in the whole satellite design stage and development stage. The hatch plates shall be uniformly designed at the design stage, and 2 or more different hatch plates of the same type shall be produced when they are put into production. In the whole satellite development stage, the cabin plate is directly installed according to the needs of different products to realize the flexible configuration of products. Compared with the flexible design of partition bulkhead, the independent bulkhead is suitable for the replacement of a large number of equipment or the configuration of new function equipment in the development stage. 3. The hardware flexibility design is realized through the transfer of secondary intermediate structure. This design can realize the decoupling between the whole satellite and the load terminal design, and meet the development requirements of the whole satellite. The secondary structure is fixed on the main structure of the whole satellite, does not transfer the main load, and does not significantly affect the structure of the fundamental frequency and vibration mode of the whole satellite. How to carry out software flexible design? The flexible design of satellite software relies on the rapid upgrading of software functions. Software flexible design is based on software hierarchical design of integrated electronic system under the unified bottom hardware resource and operating system configuration. It supports the plug-and-play of equipment and the realization of various satellite application services. In the ground development stage, plug-and-play technology are applied to realize the flexible design support of hardware. Plug-and-play technology can automatically identify access device and conduct dynamic monitoring and configuration. After the equipment is installed, it's connected to the standard power supply and distribution, information and other interfaces on the satellite, and can be found, identified, and configured independently on the satellite to meet the needs of task changes. In orbit stage, digital load technology is used to realize the flexible design of service-oriented software. According to the traditional whole satellite design, when the requirements change in the development stage, it's necessary to restart the interface coordination and satellite design with a long iteration cycle. If flexible design is adopted, interface coordination, overall design and satellite development will be changed from serial to collaborative period, which can realize new or changed configuration at a small cost and shorten the development cycle. With the improvement on user requirements, the satellite has a short period from contact sign to delivery, and the satellite life is longer and longer. Using flexible design can shorten the coordination iteration cycle at the initial stage of design and improve the volume of on-orbit satellites. The development cycle of new technologies is getting shorter and shorter, and the satellite life is getting longer and longer. Under the constraints of the limited resource of the whole satellite, improving the volume of the whole satellite is the goal that users always pursue. Based on the uncertainty of future new technology prediction and the in-depth meaning of satellite volume, it will be an important development direction from the traditional fixed resource and fixed functions to the direction of flexibility and redefinition. I'm pleased to share my report. Thanks.